Right, we are now live. Hello, good morning everyone, and a very warm welcome to the RIBA Gulf and Geberit seminar series. Thank you everyone for joining us this morning to kick off the first module of this series. I hope everyone is safe and doing well at this unpredictable time. I am Mithuna Murugesh, the RIBA Business Development Manager for the Gulf, and it's my pleasure to announce that the RIBA have recently opened up one of its first international offices in Sharjah in the UAE. I am delighted to announce that the RIBA have chosen the GCC as one of its international locations to further serve our global members in order to deliver better buildings and, most importantly, create a stronger community of architects. The recent pandemic reminds us all that we are one global community. At RIBA, we are still optimistic and we believe we must continue working with architecture communities across the globe. With this in mind, we have now opened up the RIBA Gulf and Geberit seminar series to 7 countries across the GCC, and today have members tuning in from the UAE, Kuwait, Bahrain, Qatar, the Kingdom of Saudi Arabia, the Sultanate of Oman, as well as Jordan. Today's module of the RIBA Gulf and Geberit seminar series will provide an insight on hydraulic principles of in-house drainage systems. Please do send across any questions regarding today's presentation in the chat bar alongside at any point of time, and our speaker today will attend to them in the last 15 minutes Q&A session. Lastly, I would like to thank Geberit for their kind support in sponsoring this seminar series. On that note, I would like to introduce Louise Pitt, the Marketing and CRM Manager for Geberit International Sales, to introduce us to our speaker today.
Good morning, everybody, and another warm welcome from us at Geberit. So today I'd like to introduce you to our speaker, Mr. Remo Hirschi, who is a Swiss national. He's 38 years old and he started his professional career in 1996 in the construction industry with an apprenticeship in plumbing technology. After completing his Bachelor of Science in HVAC engineering in 2012, he was engaged as a project manager in a Swiss consultancy firm based in Switzerland. 6 years ago, he joined Geberit, a Swiss headquartered multinational. Since then, he's traveled quite extensively to more than 15 countries, working for Geberit within the MENA region. And 1 year ago, he relocated to the United Arab Emirates to join the Geberit Regional Gulf Team, where he heads up product management and the technical sales support teams for the region. So with that, I'd like to hand you over, please, now to Remo for the presentation.
Yeah, also good morning from my side, and first of all, thank you very much for giving us the opportunity here to present to you all. My name is Remo, and now I will share my presentation with you just in a few seconds. So I think we are all set with the presentation. So today's topic is designing drainage without compromise, DIN EN 12056. The agenda of the next 30 minutes is a little bit something first of the company Geberit, then the history of drainage, very brief, basics of drainage systems, quite important, the material and characteristics of drainage systems we in Geberit believe in, then different drainage system types, we will have a look at this, then how to plan a drainage system in 5 steps, how to succeed, quite simple. At the end, we're going to show you quickly something about Geberit SuperTube, which is an innovation in drainage, and then we will be already at the summary and the question and answering session. So who is Geberit? We are a European market leader listed at the SIX Swiss Exchange stock market, and since 2012 included in the Swiss Market Index. We are 12,000 employees spread over 50 countries, and we have 29 production sites, which are as close as possible to our key markets. We have 3 brands, which are Geberit, of course, and also Colo and Twyford. Our business model, Here we believe into the push and pull principle. Let's have a quick look at the history of the company. It has been founded 1874 by Mr. Caspar Melchior Geberit in the town of Rapperswil, which is close to Zurich, nicely located at the Lake of Zurich. 1905, this gentleman invented the first wooden cistern, which you can see on the tiny picture already came with a flush valve and a filling valve. In 1952, this was an interesting step when Geberit produced the first plastic cistern, and then in the 50s, also drainage systems, what we are talking about today, came into the portfolio. I would say 1964 was a key year for Geberit when the cisterns went into the walls. The first concealed cistern was launched in 1964. In 1977 already, then from a simple system, all got into a system to offer to contractors more easy solutions for the installation. As well, in the same year, Geberit launched its first shower toilet. In the 1990, Geberit introduced a water supply system called Geberit MEPLA, and 2004, from the material perspective, Geberit MAPRES, also a supply system for water supply, but also for the industrial applications. 2010, this was the first, let's say, design system in front of the wall, Geberit Monolith, a very nice product for renovations. The most recent acquisition has been accomplished in 2015 when Geberit bought a Finnish Sanipex group with now having also bathroom ceramics in the portfolio. To sum up, what we can see here that Geberit focuses on three main product areas, which are installation and flushing systems, bathroom systems with all ceramics in front of the wall products, mirrors, cabinets, and so on, and drainage and supply systems. So what Geberit is very well known for is, of course, for the behind the wall products and solutions, but nowadays also for in front of the wall solutions. We invest in 10 strategic important technology areas. Today we will hear something which is coming out of hydraulics and virtual engineering, but we invest, let's say, about 2.5% of the annual net sales into research and development, and definitely Geberit will continue to do so. To sum up, Geberit can manage the entire water flow within buildings, and with our innovations we set standards in our field. So not only good products are important, we want to really focus on systems and complete solutions. Like, for example, a hydraulically optimized drainage system, which will save space and time during installation. Or, for example, the matched balance of a flush performance between a concealed cistern and a wall-hung WC. There are, of course, much more synergies which will help to build better buildings at the end of the day. So now let's go into the topic of drainage systems. If we look at the history of drainage systems, this comes from very rudimental to nowadays luxury and modern living with just flushing a toilet without even noticing where the water is coming from and where it is going to. But the biggest problem was the bad smell, the hygiene and the comfort within buildings. If we, for example, think back to the great stink of 1858 during a hot summer in London, where the hot weather in July and August in this year exacerbated the smell of untreated human waste and industrial effluents that were present of the banks of the River Thames. So the toilet or the bathrooms, let's say, they have been integrated into the buildings, and then so on, more and more a drainage system had to be developed. The key, I would say, today is, of course, the piping system within the building, but also the sewage system, which was not existing earlier times, or like in London, the River Thames was used as a sewage system. Today, of course, we also need to think about wastewater treatment plants, and I would say also most important, the ventilation of the drainage system. So what are the basics of a drainage system? To get an insight, we have a short video to look at, which is about Geberit Supertube, an innovative drainage system, but it includes the main principles of drainage, and the terms of hydraulics will be played, and we can use this video to continue then our presentation.
Living spaces and commercial spaces are in short supply, and they are expensive. They have to be flexible and adaptable in terms of both use and design. Solutions that minimize the space required for facilities like a hydraulically optimized drainage system would be most welcome. The problem: conventional drainage systems take up valuable space with their large pipe diameters and ventilation pipes running in parallel. In addition, horizontal pipelines, offset, or in the collector pipe, for example, have to be installed with a slope. Geberit Supertube solves these problems. This flow-optimized system, with its sophisticated fittings, can be relied upon for a continuous column of air in the discharge pipe. There is no need for an additional ventilation pipe. The diameter of the pipelines can be reduced to D110, and horizontal pipelines up to 6 meters long do not require a slope. This equates to a space saving of up to 20% in the vertical duct. The gain in room height equates to up to 40% less suspension distance being required. More space with no loss of performance. With Geberit Supertube, the maximum discharge capacity is 12 liters per second. Geberit Supertube consists of the Geberit PE Sovent fitting, Geberit PE bottom turn bend, and Geberit PE backflip bend. Geberit Sovent sets outflowing water in rotation and guides it around the floor connection. Inflowing water can flow in without a hydraulic blockage being created. The air column in the stack is maintained. In the case of a change in direction, for an offset, for example, a bottom turn bend is built in. The annular flow becomes a layered flow without disrupting the column of air. This change significantly reduces impulse losses compared with conventional bends. As a result, there is no need for the pipes to be installed with slopes. At the end of the offset, the Geberit backflip bend sets the water in rotation again. The air column is maintained. This is how optimized hydraulics can create more living space. Geberit Supertube offers yet another benefit: simpler planning of the system and even faster installation. And that's where Geberit comes in. Take advantage of Geberit's personal project service for planning, implementation, or directly at the building site. Geberit Supertube, the space gaining system.
Okay, that was a good introduction. I took some notes again. Of course, I have seen the video some several times, but it's always again interesting. What we could hear was a lot about air column. So the hydraulic blockage when inflowing water is flowing into the main stack, the air column is maintained. I heard about 2-3 times, and no disruption in the column of air. And we will come back to that, to these terms over and over again in the presentation. But what are the requirements now of a drainage system? So what we could hear was, number one, the hydraulics. So every drainage system, no matter which standards you are following, which materials you are using, these requirements are valid for every drainage system. So the hydraulic, we don't want to have any odors to escape from the trap into the building, so the bad smell, which we can control with the water seal in the traps. A system needs to be corrosion resistant, so we're talking about durability, same as here with temperature resistant. If we think about kitchen drains, for example, It needs to come with a good mechanical strength. This goes also into the topic of durability, which we're having here. Low sound influence. Acoustics is in general quite a big topic when it comes to building construction in general, but also in the drainage, let's say in sanitary as a whole, we want to avoid noises in unwanted areas. The system needs to be easy and safe to install, not too complicated. Of course, a good engineered solution is always as simple as possible. So the main requirement of the drainage system is that the waste and soil water, solids and liquids, should be carried away quickly, quietly, without blockage and without the escape of foul air into the building. That's very basic, but at the end of the day, this is what the drainage system, no matter which one, let's say, needs to fulfill. If we look a little bit closer, we have here a front section on the left side and the cross section on the right side of a drainage pipe. We have three main elements, which is air, dirt particles, waste and other stuff which is drained away, and of course water. And the most important of all of these three is the air. So as a quick example, to drain 1,000 liters of water, we require about 20 to 35 times more air to drain away the water. So this ratio is crucial for a drainage system. Furthermore, the filling ratio, we need to have a closer look. That means the filling ratio is the relation between the height of the water seal and the inner diameter of the pipe. And if this ratio is between 0.5 to 0.8 maximum, we talk about a sufficient flow, first of all, of the solids and the waste and soil water, but also we have stable conditions in terms of pressure. So this is basically what we want to achieve, to have a ratio between 0.5 and 0.8. If this ratio is below 0.5, what we see here in the middle illustration, water height is too low, so you can imagine the flow will be insufficient. So this can cause stagnation and blockages. Imagine a long collector in the basement, oversized, for example, and then there is a risk of blockages and insufficient flow. If we have, on the other hand, a filling ratio which is more than 0.8, so the air which we have seen before, the 25 to 35 cube meter for 1,000 liters of water, will have no more space, simply to say, to circulate, and no air in a pipe will cause a siphonic effect. A siphonic effect will empty. Let's say you will have an underpressure in the pipe system. It will empty the water seal in the trap, and afterwards the bad gases or the bad smell can enter the bathroom again. So we really want to make sure that always we have a filling ratio of 0.5 to 0.8. How can we achieve that? By appropriate sizing and adding slope gradient to each discharge pipe. So every section of the drainage system need to be identified. What do we want to drain? How much water? Where is it installed? How much slope we can give? And then we can simply engineer the system to be on the safe side. If we look at the air circulation and the water flow in vertical pipes, then here important is to understand that the water is guided around the pipe, what we have seen also in the video, and in reality we have a resistance from the pipe itself, from the pipe wall, for example. We have an air column, so there is a resistance. Because theoretically, what we can see in number 1, the graph, what we see here on the chart, we have the velocity and speed of the water column from 0 to 25, and the height of the stack from 5 to 35. Theoretically, what we can see also from the formula, the only variable is the height. So this speed would increase in relation to the height. But actually, what we have in number 3 in a real scenario, we will reach a maximum velocity after, let's say, 35 meters in the building of 13 meters per second. This is important to understand because a higher speed will also cause negative pressure in a system. If we talk about materials and characteristics, so we at Geberit, we believe very much that high density polyethylene, HDPE, is the best suitable material for drainage systems. A lot of characteristics which are for this material. It's very much resistant against corrosion, impacts, chemicals, temperatures, UV. If it would be installed outside the building, for example. We can achieve also a permanent seal by welding the material, which is definitely also another advantage. So a drainage system always comes, of course, with a lot of different components, what we can see. So in the end, we need a maximum of, or let's say the most relevant components to really design a hydraulic optimized system. And as mentioned, good engineering is simple and with a reduced complexity. Furthermore, to HDPE, there are several jointing techniques available with this kind of material. So the two most used are the butt welding. So just simply by heating up the material and putting together two pipes or two fittings, for example, adding pressure, we can achieve a good welding. Or there are electrofusion sleeve weldings. Also, we know the socket principle, ring seal socket, expansion sockets, and also screw threaded joints or flange connections, depending on the application. So to quickly sum up the material, it is very easy to cut and handle, and also very strong and reliable jointing once a contractor is a little bit familiar with the material, which is very easy going. And now drainage system types. So this is quite interesting to see here a brief overview. On top we see with system types or system layouts with an European influence, and on the bottom a British American influence. So we need to separate the system in two main parts. First is always the vertical stack, and secondly the horizontal pipe collectors. So we differentiate here on single stack system versus triple stack or dual stack system. And for the horizontal part, where we install the pipe, is it cross floor, so below the ceiling, inside the slab, the concrete, or is it the same floor installation, which means we keep the pipes in the same bathroom. And then obviously also we have floor drains or a different use of applications from region to region. Definitely what we see in the GCC region is triple stack cross floor, dual stack cross floor as the most. Where Geberit is coming from, Switzerland, mostly we see single stack and same floor installations. So at Geberit, what we think is we would like to achieve a simplification, but without a compromise in the functionality of the drainage system, what we have seen. So we must comply with all these characteristics or fundamentals of a drainage system, but we would like to simplify the solution. Of course, a single stack, same floor drainage system in the region in GCC is not something which is possible at the moment. We have a floor drain and a cross floor installation. I think this is a step which is not, which we cannot change just from today to tomorrow. But definitely what we can look at is the simplification of the stack system. So from two stacks to one single stack without a hydraulic compromise. So how can we do that and still following or complying with standards? So if we look at the EN 12056, we need to understand this drainage standard is valid, or let's say relevant, for what is happening inside the building. When it goes outside for the, let's say, plot drainage, then we have other standards which then vary from country to country. But as a fundamental standard, we have the EN 12056. If you look at the 12056, this standard comes with 5 parts and 5 chapters, so to say, and the part number 2 is the one which defines the layout and the calculation, let's say the designing of the drainage system. So let's look into the standard number 2, into the part number 2 of the EN 12056. So here you see 12052. Here, first of all, there are 4 different systems which are defined, and the definition of the system comes back to the filling ratio. So we have system 1, which is in dark blue color. That is the system which Geberit is, let's say, following or believing it is knowing it is the best working practice. And here we have sanitary appliances which are connected to a partly filled branch discharge pipe, so the horizontal branch pipe from the let's say WC to the stack, and which is designed with the filling degree of 0.5, and which are connected to a single discharge stack. So to quickly recall, this is what we have seen here in the beginning, and system 1 is based on that principle. We have other systems which are also in the standard. System 2, which has a little bit higher filling ratio, up to 70%. System 3, which previously or in previous years was more common in the UK. I think in the UK also now the shift is more towards the system 2. And we have in France another system 4, which is in practice. But we focus on system number 1. So how then to plan a drainage system? 5 easy steps to succeed. So what we need, of course, first of all basic information. Then we need to do a rough or a basic calculation of how much water we need to drain. Choose therefore the right drainage system. We will see that there is different options available. Then we are planning and dimensioning the stack pipes, then the branch pipes, the horizontal ones, and at the end we are dimensioning the collector pipes at the bottom of the building. So what are the necessary basic information? Of course, we need to have the architectural layouts. We need to know how many devices we want to drain. Then we need to create a schematic drawing to know which bathroom is connected to which stack, so that we can see on the schematic what is drained per stack. And we need to know the building type. Is it the hotel? Is it the residential building? To determine the frequency factor. So once I have all this information, I do a calculation. It looks not really complicated. It's quite simple. So we have a frequency factor, which we just will see the different factors. That is depending on the type of the building. We calculate the sum of all discharge units. So a discharge unit, we will see also later on the table, a WC, a wash basin, a shower. Every fixture has its discharge unit in liters per second, which defines, let's say, the flow rate of a unit. Then we put that in this formula. So the frequency factor times the sum of all the design units, and we take the square root. And here is a small example. So a residential building with 576 design units would give us 12 liters per second, which we would need to drain away with our drainage system. Here you see the overview of the frequency factor. So we deal with 0.5 and 0.7 for residential buildings or hospitals, schools, restaurants, hotels, where if you think on a hotel in the morning or in the evening, where the frequency of use of appliances will be higher. Public toilets, a football stadium, for example, when there is a break, definitely the frequency will be higher accordingly. So if we are knowing the value of our waste and soil water to drain away, we can choose from the standard a different system. What do we know? We have a single stack system. There is the parallel vented system direct, so we add a separate ventilation, or we also can have this ventilation indirectly to the stack, or then there are special solutions on the market, which one is Geberit Sovent or Geberit SuperTube. So what is the difference of these different systems? Here we see an overview. On the chart we have the liters per second, so the capacity of every system, and here we have the dimension of the stack pipe. So first of all, we have from 110 to 125, then to 160. So by increasing the diameter of the pipe, you can imagine the bigger the pipe, the more water, the more air theoretically can circulate. But also not to forget, a very much important point is how we are going to connect the horizontal drain pipes. So how we're going to connect the bathrooms to the stack. So here we have different types of fittings, and we can categorize these fittings into 3 categories. So we have 88.5, let's say sharp angled fittings. We have swept entry fittings, which are hydraulically a little bit optimized. You can see the shape here. Or we have Sovent fitting, what we have seen also in the video. And the great advantage of the Sovent fitting is that it separates the inflowing water from horizontal to vertical and does not interrupt the air column which is in the stack. So we can always imagine if water is flowing in the stack and water is coming down, so there will be a turbulence if 2 water columns coming or meeting each other in the fitting. So therefore, not only the diameter is relevant, also the type of fitting, and then we add separate ventilation. So here we see, for example, for 12 liters in our example, we could use a 110 stack with a Sovent fitting. We could use a single stack 160, increasing the diameter, or we also could use a parallel vented 160 with a 90 parallel ventilation, which has all then a capacity of 12.4 liter. So here, let's say there are different solutions with the same capacity, and at Geberit, we believe that keeping the system small has the most benefits in terms of space, installation, complexity, planning, etc. So here we see basically the same information just explained, just in a different format. We have, this is a snapshot from the standard, how this is then divided from different systems. So a stack system, and with the different branches we are having, here you see the diameter, and then what is crucial is the maximum load. So as mentioned, for the example I have shown, let's say 12 liters, which would be already quite a high-rise building. Theoretically, we would have 1, 2, 3, 4, 5 options, but out of these 5 options, only 2 would make sense for an MEP consultant. So either you would take a double stack system 160 with 90, or a single stack system 110. Going forward, planning and dimensioning of the branch discharge pipe. So here we have single branch pipes, so it means I only have one device to drain, or a collector branch pipe. So for these branches, we find this table in the standard, which here you now can see the design unit per fixture. So for example, the wash basin has 0.5 and the single connection diameter, which is recommended. Here we have created a separate chart with the Geberit recommendation, which is based on our knowledge and experience of the past years. So going back here, according to this table, then I can define and dimension my branch pipes. For the collectors, underground and collector pipes, there are two tables in the standard. Also here, it is about the filling ratio. The table above comes with the filling ratio of 50%, and then what is relevant is the slope and the diameter of the pipe. So for example, if I have 12 liters to drain and I can add a slope of 2.5%, I would need a 160 horizontal pipe. So according to the slope, I can, let's say, what is given, of course, is the flow. I can sometimes, we know that the slope is crucial, but also difficult to apply. So here we play between 1% and 2%. We know our value, and then we define the diameter. There is a separate table for a filling ratio of 70%. So meaning the filling ratio from 50 is then going up to 70%. Then here also we can say that this varies from municipality to municipality, where we need to use which filling ratio. Means where in the building. Coming back to Geberit SuperTube now, definitely we can say that nowadays space is a precious good, and with the hydraulically optimized system, we definitely can save some space. So back to our example, we could either have here a 160 with a 90 ventilation pipe to drain our building. Nowadays we have offsets in hotels, in multi-use high-rise buildings as well. So if we, in the case of an offset, also here there are rules to follow where to connect a fixture, for example, in the change of direction, and we need to have a slope, obviously, and then we continue downwards. With Geberit SuperTube, what we have seen just in the video before, it offers simplification by having just a 110 down pipe up to 6 meters without slope. So another opportunity to save space, or at least to simplify the coordination. And to summarize, both solutions here have the same goal to achieve, what we discussed in the beginning, but we can do that let's say in different ways, and we believe as simple as possible offers for all stakeholders in the projects several benefits. A quick look again to the key fittings within SuperTube. So the HDP solvent fitting 110 is definitely the heart of SuperTube because of the inflowing water here, the hydraulic optimized guidance around the connection allows us to maintain only the 110 diameter. With this fitting, this wouldn't be possible. The bottom turn bend to change the annular flow into the laminar flow. So also what we could see is there is no change or significant change of pressure within this section of the building. So also here, in certain circumstances, we can maintain the 110 diameter, and the backflip bend after the offset, after maximum 6 meters without slope, we can then go back into the stack pipe. So to summarize This is offering a simple, space-saving, and truly innovative solution for drainage systems, mainly in high-rise buildings, from top to the basement. So with hydraulically optimized drainage system, we can save space in floor area, but also in room height. It is easier to plan, so we can save time in planning, and also the coordination process will be simpler, less pipes, less complexity. And if we are thinking about the installation, smaller pipes, smaller dimensions, no ventilation, makes it just much easier on the building site. As a summary, we would say that safe drainage systems are not mere coincidence. Of course, it's based on good materials, clear standards. Definitely, in the industry, we have many years of experience in hydraulics and flow technology, and also numerical CFD simulations nowadays help to improve systems, and we have exceptional test facilities that are beyond state of the art to test and search for innovations and come up with new solutions. So at this stage, I would like to thank for your participation, and we would go to the question and answering session.
Apologies, everyone. I happen to be on mute. Thank you, Remo, for that wonderful presentation. As an architect myself, I can say that was very interesting and a great lesson. At this point, we will move to the Q&A session, which will be limited to 15 minutes. Please do submit your questions regarding today's presentation on the Q&A bar on the right if you haven't already, and Remo will answer them.
Yeah, so we have a question. What is Geberit doing with regard to grey water recycling? So here what we can say, yeah, Geberit has a siphonic roof drainage system, which can be an opportunity to easier collect rainwater from a larger surface and to transfer them to a filtration station or to a collecting point. That is definitely, I would say, the contribution to grey water recycling. There is another question. So with Geberit single stack system, does it mean vent cowl at top of the stack is not necessary, and it is commonly provided for a British standard single stack system? A vent cowl. So definitely what is the key is that all the stacks are ventilated outside the building. So we continue with the stack pipe on the rooftop and provide the air circulation. But I mean, it is a must to have an open communication between the sewage and, let's say, the outside of the building. Is there a maximum length of horizontal run with super tube? Well, without slope, it is 6 meters, as mentioned. Then after 6 meters, we convert into the conventional dimensioning. So basically, then it could go yeah, as any other collector, as long as any other collector. But with the super tube, let's say what we have there, this the 0% slope is up to 6 meters. There's a question from Mr. Tantawi. Is Geberit super tube supported by international plumbing code? What we can say here, in the UAE, for example, we have the first project approval by a municipality. Definitely, it is not a subtube is not a part of the plumbing code itself, but the experience or the approach we are having is we are designing and following what we have seen, the European standard. Definitely, when it comes to the technology itself, I mean, this has been invented only April 2 years ago, so it's very new on the market, and it has not been adopted by international plumbing code yet. This is always a collaboration between the manufacturer, the consultant, and the developer, and then approaching the municipality to obtain approval. But definitely here, this is a green field, and we need professional support to prove the system in the market and to show that plumbing codes definitely can be enhanced with new technologies. There is another question from Robert. The subtube bottom vent tube has a vent. Where does the foul air vent to? So no, the bottom turn vent is a closed fitting as such. There is no vent, so there is no air coming in or going out from the fitting itself. In the bottom turn vent, only the smooth transition, let's say the shape of the fitting itself allows us to convert the annular flow into a laminar flow. So let's say we can provide the air circulation throughout the fitting just by shaping, and of course a lot of study and research and fluid simulation. How can we know the discharge unit? The discharge unit can be found in the standard in the table. So every fixture is defined with the discharge unit. There, Robert has another question. We have a project where the buildings are connected to project-wide vacuum sewer system. Can you comment regarding any issues connecting subtube system to such sewer system? To be just very honest here at this point, we would need to have a deeper, closer look into that. How this is designed, how the plot looks like, the buildings, and so on. But definitely, yeah. I mean, yeah. No, I think this is an interesting question, and it maybe would be interesting to get in touch to discuss more about that. Can you please repeat the material used for the piping? That's HDPE, high density polyethylene. There's another question from Robert. The video noted there was a vent in the bottom vent. Yeah, I suggest you contact me over my email. We can have a phone conversation on both the topics. Okay, I don't see more questions coming in. And for, I mean, all the video and so on is available on YouTube. Geberit has a YouTube channel with all relevant videos, and also on our website, www.international.geberit.com. You find all information and videos, links to SubTube, and of course every other products, and all information related to the company itself, like annual financial statements, reports, can be found on www.geberit.com. Yeah, I think that was it. Thank you very much. And thank you very much to RIBA as well for giving us this opportunity.
All right, thank you very much for that seminar, Remo. That was very interesting and a wonderful beginning to our series. I would like to thank our audience spanning across 7 countries in the Gulf today as well. The RIBA with Geberit will be conducting the second module of this series on June 11th, which will cover the subject of siphonic rainwater systems. We have attached a link to register for this event in the Q&A section alongside, so I look forward to seeing all of you at the next event. Thank you once again, Luis and Remo, for the wonderful presentation. And I would like to thank Geberit once again for their kind support in sponsoring the RIBA Gulf and Geberit seminar series. Thank you, everyone. We hope to see you at Module 2. Thank you.